This is a demonstration of the control system for the wick drain. We're going to start off by going through the human-machine interface, and we're going to try and configure the unit. After that, we're going to try and go through an operational phase. On the screen, we've got the two buttons that we could use. There's a configuration where we can configure the various parameters of the recorder, and then there's the operation screen, which allows you to observe when you're operating the unit and what it's recording and so on and so forth. We'll go through the configuration. Configuration, you can configure the mast, the pressure, and the inclinometer. These are the pressure valves. One is for the forward pressure when you're actually driving the wick into the ground, and one is for the reverse pressure when you're driving the wick out of the ground. So what we'll do is we'll start with the pressure setting. The whole system is designed to start recording various telemetry data when we're actually driving the wick into the ground. So what we have here is when you start increasing the pressure to a certain value, we start recording the data. And what we have is a forward recording pressure. We have the reverse recording pressure, so that the forward is for start the recording, the reverse is for stopping the recording. And we also have the pressure spike time. It's a start-stop time delay. So for example, the pressure has to go on for a period of time before we start recording. It's set to 0, which means that at this point in time, when the pressure exceeds 0.05 megapascals, we'll start recording, and we'll start recording immediately. So we'll leave that one as it is for the time being. We'll go on to the mast configuration that configures everything to do with the mast for the wick drain. We can here configure a mast length and an absolute mast length. We can configure a minimum position and an absolute minimum position. The absolute positions are really designed to let you know that you've just gone beyond what is the limit. The minimum position is usually, for example, if we look at the mast length, that's 20 metres, the absolute mast length is 21 metres. But if you exceed 20 metres, you get a warning that you've just exceeded 20 metres. If you exceed 21 metres, you get another warning saying that you've basically exceeded the absolute limit. The mast minimum position is set at 1 metre, so again, if you go to 1 metre upwards, you've reached the limit. If you go below that, you get a warning. If you go below 0, you get an absolute warning, and I'll demonstrate that later. And the update depth, this system is designed to send a record of data to a recorder every unit of depth, and that is configured here. So you can configure it for 1 metre, you can configure it for half a metre, you can do whatever you like with it. So you configure it to say 80 centimetres. So now whenever we're recording, it'll update the data every 80 centimetres. I'll leave it at 80 centimetres, it'll be good for the test. And finally, the level configuration. We have an inclinometer here that warns the user of the wick drain whenever they've leaned the machine too far in the X or the Y direction, and you can configure at what point you would get a warning. At the moment it's set to 4 degrees in the X and 4 degrees in the Y direction, so if the mast leans beyond 4 degrees, you get a warning on that one. And that's pretty much it for the configuration. If we go to the operation screen, we can see some of those things. Here's the operation screen. We have before us the forward pressure, which is 0 at the moment, the reverse pressure, which is 0 at the moment, so the machine is not in operational stage. The mast depth, this is how far we've gone into the ground or out of the ground, and as I rotate the encoder, the mast depth increases. As I rotate it in the other direction, it decreases. When I get to the 1 metre mark, I get a warning in yellow to say I've exceeded the minimum position. if I go beyond the 0 mark, which is what we've set it to, I get a red warning, so I've just gone too far. And so you need to operate it in the white position, but if you get to the yellow position, then you've gone too far. And similarly, if I've gone beyond the maximum length, I would get the same error. Inclinometer is right here. You can sort of see where you're at. Can you see that, Eddie, on the screen?
Yes.
And you can see if you've gone beyond the 4 degrees, you get a warning in the X. If you go beyond 4 degrees in the Y, you get another warning. If you go beyond 4 degrees in both directions, you get 2 warnings. And you can see the crosshairs changing here also. Right. Then down here we've got the TC3 comms. It's in green, which means that there is communication between the recorder and the programmable logic controller that is actually crunching the data. The recording is not on at the moment. We're not recording anything because there's no pressure on the forward. Vibration on the machine is on and off. That's set by an input. I'm going to go and turn the input on and off, and you will see the vibration, the second last value here, change between green and white. So the vibration is off at the moment. The vibration is on. Vibration is off. And lastly, we've got a button to cancel the recording. If you started recording and you're not happy with the data or something is not right and you just don't want to have a whole lot of files on your recorder, you can just cancel that part of that event you're doing at that point in time. Alright, now that we've demonstrated all this, let's just go ahead and simulate what would be an insertion of a wick into the ground. The machine is ready and it's in position. There's no recording at the moment. The driver is about to drive a wick into the ground, and that's going to increase the forward pressure and will start the recording. So there it's on, and there's also a flashing light over there to say that he is actually recording at the moment. Record of data has been sent to the TC3 recorder at the moment to record certain things. And now as we move in the forward position, every 80 centimeters the recorder will get a line of data. Got one? Oh,
Yep.
you won, yep, that's fine.
I'll go closer to
No need.
Okay.
No need. So we should be getting one at a 1.6. So you should have 2 lines of data. 3 lines of data. 4 lines of data. 5 lines of data at 4.15 meters. Now what we'll do here is he's gone too far into the ground and he needs to increase the pressure, and he needs to turn on a vibration to force it further into the ground. So I'll actually go and turn the vibration on. So he's turned on the vibration. What we have now is another record at 4.15 meters, and we continue with that. 4.3, 4.4, 4.5, 4.7, 4.8, 4.9, and so on and so forth. And assumingly he stops at 5.43 meters, and that's the end of the insertion. He will release the pressure, and we'll go ahead, and he's about to finish up, and we need to pretty much go ahead and put on reverse pressure. Excuse me. And here we have reverse pressure on. The recording is finished, and we should have a file of the recorded data pertaining to an insertion process. The light here has gone off. It went off when we did it, is that right? And I'll turn off the vibration again. Alright, and from here we will take our data. We'll take a USB, if we can zoom in on the TC3. Yep. So there's a record of data here. We'll plug this in. So the two noises implied that the USB was detected, and the last event implied that the data has been uploaded to the USB. We'll unplug it. And I'll just plug it into a laptop.
Own goal and 3 others.
Yeah, let me do that. You just. We'll just wait for the USB to be detected. Alright, so the USB is not detected. We'll grab another laptop that works. Yep. Let's just go over here.
Okay.
Plug it in. Just you can. Yep. Yeah, where's your mouse? There it is. I'll open it up. And then we go to a folder called Work Logs, and we go to
The last one.
the last one, which is
N16.
yep, 1016. So it's this one here. That's the log of data we just recorded, and there is our data. We can just zoom in on our data.
Yep.
We've got the date and time right here. We've got the GPS coordinates, longitude and latitude. We've got the inclinometer readings to basically show that you've gone in straight. And you've got the times, the insertion forward pressure, reverse pressure, which naturally was static throughout, the depth at 0 point, at 0.8, at 1.6, which is exactly what we had, at 2.4, at 3.2, at 4. At 4.15 we turned on the vibration and continued. At 4.8 there's another reading. At 5.43 meters we stopped and we turned on the reverse pressure, and we finished at this point in time. So with this data you can ascertain as to how far what the machine has done, and every time you make an insertion you get one of these records.